All right, hello folks. We're gonna do number 34 together. This is a synthetic division problem. I know it's not real hard, but I'm gonna go through this one because I'm gonna show you how to check your answer. And that's gonna lead us into the next little bit of notes that we're gonna talk about, like the factor theorems and stuff. We're not gonna do too many examples today, but we'll do a few, okay? So here we go. 34, we're dividing by x minus 2, which means that when I set up my synthetic division, what number goes on the outside? Positive 2, right? X minus 2, we set them equal to 2 or equal to 0, whatever, okay. Carter said these guys go in order and we're not missing anything, right? Do you always check that?
Yeah.
You should. And 24. Okay, so there's that. Ooh, this is a long one. All right, can I go fast?
Yeah.
Ready, set, go. 2 and 4 and 17 and 34 and 31 and check and make sure I'm doing this right.
Yeah,
And 62 and 4 and 8 and negative 12 and oh baby, negative 24 and 0.
Yep.
Man, oh man.
Yep.
Okay, so it was x to the 5th divided by x, so that means I have x to the 4th first. So 2x to the 4th plus 17x to the 3rd plus 31x squared plus 4x minus 12, and then there's no remainder. Okay, here's how you check your answer. Ready? Okay. This is one that I probably would not check my answer just because it does come out evenly, and the chances of it coming out evenly and me doing it wrong are probably, like, I probably did it right if it comes out evenly, but here is the rule. Are you ready? If we're dividing by x minus 2, okay, again, we do the whole x minus 2, we set it equal to 0, and that means x equals 2. Here is the rule. 2, I should be able to plug the number 2 in to here, and here, and here, and here, and here. We plug it into the whole thing, and it's going to come out, and it's going to be equal to the remainder, right? Yeah. So I can kind of check my answer to make sure I did it right by plugging in the number that I'm dividing by. After I set it equal to 0, I plug the number in to the top, and the answer that I get should end up being whatever my remainder is, right? Okay? I would especially check that because sometimes you'll end up with a remainder. Did you guys get any weird wonky remainders?
Yeah.
Like sometimes we'll get like 116 as a remainder, and I'm like, I think we did that wrong, right? You can check by plugging the number in, and you should get 116 if that's what you got as a remainder, right? Like that's how you can check your answer. And chances are, if this number's correct, all of the stuff before it is correct. Unless you made a mistake twice, right? Like an undid your mistake, you know? So, if your remainder's correct, chances are the rest of it's correct. Does that make sense? Okay? So, that's how I would always check. Like when you're taking a test and I give you a long or synthetic division problem.
Would you
plug
grade
it
us
in.
on like the stuff before if the answer's right?
What?
Like if our reminder's right, would you even like check it?
Yeah, I would check the beginning stuff. Yeah, probably. Yeah, usually. Like, because that's part of the answer. I don't know. It depends on what I was asking for. If I was just asking for the remainder, I'd just check the remainder. I don't know. Anyway, okay, so that's that. That was 34.
Ooh.
Okay?
Ooh.
Okay, and that kind of leads us into, don't write the 116 down. That has nothing to do with it. I just made that up just now. La, 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 la.
How
Okay.
long have you got next problems?
Not terribly long. I don't think. There's, example 7 might be a little bit long.
Oh.
Yeah, this guy, hold on. This guy might take just a bit of time. Example 7.
Because I might have to get another piece of paper.
What?
Yeah, I'm gonna get it.
Oh, for your homework or what? Oh, yeah. You'll probably need another homework prep page, I'm guessing.
I just started shoving everything together.
Okay. This is going to be so fun to grade. Woo.
Bill, you want one?
Do me a real quick favor and on your paper, circle the answer so that I can see him real
No, thank
easy.
you.
If you wouldn't be
No,
so
because
kind.
you don't give me 100.
What?
You don't give me 100.
Circle your answer on your homework page so I can find him easier. Circle or box or do something pretty. Or highlight if you want to be like one of them that highlights. Josie and Reese, if they're watching this, you guys are highlighters.
I got a pink highlighter.
Sometimes highlighting your answer. Yeah, sure. Okay, good. Can I move on? All right, so the factor theorems. Here is what the factor theorem says. Let's do this. Given, it says, well, we're using the remainder theorem. This is example 6. So it says use the remainder theorem to evaluate f of 2. All they're saying when we're doing f of 2, plug 2 in. You guys can do this in your calculator if you want.
Time out.
Hold on, let me write this down. We are plugging 2 in, and it's a lot.
Why? How did it 2?
You like this guy?
Oh, I'm on the answer right there.
2 to the 4th is 16. 2 to the 3rd is 8 times 6 is 48. So somebody take a running total. 16 plus 48. This is 4 minus 48. Hey, that cancels. Boop. Get rid of those. Minus 60 plus 35.
-9.
Negative 9. Okay?
Well,
Yeah? Now, that means, before we move on, that means if I were to take this guy and divide by what?
2.
Not 2.
-9 would be 0.
X minus 2. If I was taking this polynomial and dividing by x minus 2, do you understand why it's x minus 2?
Yeah.
Yes, because you set it equal to 0. Okay, so if I were dividing by x minus 2, I would get -9 as my remainder. Does that make sense? Okay, let's do the other one. -7. You're going to have to type probably this whole thing in because I don't know what these are.
Okay, I'll
6, -7 to the 3rd, minus 12, -7. If you don't want to write it out, you don't have to, but there's that. Plus 35. Okay, type all of that stuff in. See what you get. Yeah? Sure.
Oh,
7
crap,
to
I got a
the 4th.
big number, which I don't think is right.
Minus 6.
What'd you get, Carter?
Dang it.
What'd you get?
Well,
I got -3626.
Oh, if I could find my calculator.
I got 0.
Oh, check.
I got 0.
You're right. What?
And I'm going to say that I'm right.
Alright, did you put it in parentheses?
You got a 0?
What'd you get?
Matthew got 0. Right? Right? Did you get Matthew? You're going to type it in right.
Yeah, did you put parentheses for it?
Yeah, you got to put parentheses. And you got to make sure you don't screw up your negatives.
How do you insert a parenthesis?
I don't know.
Parentheses.
The parentheses button.
How do you insert though? Where's the insert button?
Oh. Second delete.
I think my calculator's dumb sometimes.
I already did something.
No, like, I usually don't get the same answers as everybody else.
Yeah, I got 0.
I can plug the same thing as anybody else.
Right?
I got 0.000.
And I'm going to also I don't have to delete that one because
I plugged it in just like you have on the board.
No.
6, 7 to the
Don't
3rd,
deserve,
minus
like-
12.
Why not?
You'll never
Insert
get
Insert minus
Insert.
30.
Open it.
It's a mess.
What is happening to you?
It's a mess.
Great.
It's a big mess. This book is ruined.
12, 7 squared, 7
dangerous.
I'm just writing for one.
Hey, there we go.
We gotta recheck here.
I got 0.
There you got 0. Okay, the answer is 0. So that means that if I were to take this guy and divide by what?
0,
Nope.
negative
What am I dividing by?
7.
X plus 7. I'm taking that guy and I'm dividing by x plus 7, and you get 0 as a remainder, which means this is a factor. Do you know what a factor is?
Nope.
Of this. A factor is a number that goes into it. Like 2 is a factor of 6, right? 2 goes into 6. 2 is a factor of 50 because 2 goes into 50. This guy goes in here perfectly. So he is a factor because he has no remainder. Make sense? So if they ask for that, if they say, is it a factor? They're just saying, does it go in there evenly? Right? Make sense? Good? So, blah, blah, blah. We just talked about that. Okay, let's go to example 7. Let's go to example 7. One thing right here. Yeah. A, it says use the remainder theorem to determine if the given number C is also a 0 of the polynomial. So I want to know if 4 is a polynomial. So 4 is a factor, is a 0 of the polynomial. That means if I would take and divide by x minus 4, would it go in there evenly, right? I can just plug 4 in and see if it comes out to be 0. So 2 times 4 to the third. I'm just plugging 4 in. Minus 9. I get 4 to the third is 64, 128. Minus minus 64, minus 52, minus 9. No, that's not going to come out to be 0.
3.
I got
But what does it come out to be?
3.
3. So it says determine whether this number is 4 a 0 of that polynomial.
No.
Or in other words, does 4 go in there evenly? No, because he will have a remainder. So A is no. He does not go in there evenly. He's not going to cross at 4. Make sense? Okay? All right. The square root of 3. The square root of 3. Okay, do you guys want to know how to cheat?
No.
You ready? One thing real quick. One thing real quick. Ready. This is really important. If the square root of 3 is a factor, then the negative square root of 3 is also a factor. Okay, let me explain that. So if the square root of 3 goes in there perfectly, negative square root of 3 also goes in there perfectly, right? Okay? And the reason for that is when you do the quadratic formula, you never have the plus without the minus, right?
It's plus
Unless it's plus minus 0 or whatever, right? But it always goes plus and minus together. So if the square root of 3 is a factor, then the negative square root of 3 is the factor. So, you ready for this? No? That made no sense? Like when I go to do the quadratic formula, negative b plus minus the square root of blah, blah, blah all over 2a, right? If this guy ends up being 3, I know that positive 3 is a factor, but I also know negative 3 is a factor. Negative square root of 3 is a factor as well. That's just the rule. If you have the square root of something, the negative square root of that same something is also a factor. So that simplifies my life a little bit because I know that if the square root of 3 goes in there evenly, then negative square root of 3 goes in there evenly. So rather than plugging the square root of 3 in, I could multiply those two together. What's the square root of 3 times the negative square root of 3? Negative square root of 9, which is just negative 3. So I can check, and if negative 3 goes in there, then he works. You just plugged in the square root of 3, but if you plug in negative 3, it should work as well.
Can I try
Right?
it out?
Sure, try it out. Carter plugged in the square root of 3 and he said it worked, but plugging in the square root of 3 is going to give us ugly numbers in the middle, whatever. If I plug in negative 3, it should also come out to be 0. That's just what should happen. Yeah? Like negative 3 cubed is negative 27. This guy would be plus 9. Plus another 9. Minus 3.
I got 0.
Yeah. Oh, wait. I didn't do that right. Minus 3. I don't know. I screwed up somewhere. You got 0
Did you get 0?
to come out? That's what you should get, right? I don't know. I screwed something up. I screwed something up. Anyway, you should end up getting 0, yeah? Okay? So that's how that works. Got it?
Oh, we got imaginary numbers.
Okay, this guy. That's why. So I introduced that in the last section. How do I plug 1 plus 2i in here and figure out if he works?
We don't know.
I don't want to do that. If 1 plus 2i is a factor, then 1 minus 2i is also a factor. His conjugate is also goes into there, right? Okay? So if I were to multiply those two guys together, 1 plus 2i times 1 minus 2i, if I multiply those guys, I would end up getting like 1 minus 2i plus 2i minus 4i squared, yeah? Yeah? So these two are going to cancel out. This would be plus 4. So I can just plug 5 into here and see if it comes out nicely. Does that make sense? Rather than plugging in this guy, I know that if he goes in there perfectly, his conjugate also does too. And I can multiply those together. and I get 5, that means 5 has to go in there. And if it does, then this guy is a 0. If it doesn't, then he's not a 0.
It's not, it doesn't.
It doesn't, right? 5 cubed is 125
Minuses.
plus 5 plus 10. That does not come out to be 0. That comes out to be like 140 or something like that, right? So, no, he is not a 0. Does that make sense, though?
Why can we multiply them together? What's that about?
Because anytime you have a complex like number, right? Like the square root of 3 is a complex number. 1 plus 2i is a complex number. If he goes into a polynomial, his conjugate also goes into that same polynomial. So I know that if 1 plus 2i works, 1 minus 2i also would have to work, right? So in order to just like kill 2 birds with 1 stone and make my middle work easier, I multiply them together to begin with, and I got 5. I would rather plug 5 into here than plug 1 plus 2i into there, because it's really disgusting, right? Okay, so we found out that when we plug 5 in, it doesn't work, so that means 1 plus 2i doesn't work. Also, 1 minus 2i doesn't work, right? Okay, good? Makes sense? Kinda-ish? All right. Let's move on to the next thing and let's see what we get. Okay, here we go. Example 8 is similar to example 7. It says use the factor theorem to determine if the polynomial is a factor. I don't want to actually divide this. Here is my polynomial. I want to see if x minus 3 goes into there, right? So let's find f of 3. Let's plug 3 in, right? Not negative 3, 3. 3 to the 4th minus 3 to the 3rd minus 11 times 3 squared plus 11 times 3 plus 12, okay? 3 to the 4th is 81 minus 27 plus 99 plus 33 plus 12. Somebody wants to keep a total of that instead of typing them all in. See, I do this stuff, like some of it in my head, so that the parentheses don't screw me up. And I get 198. Somebody else.
I got negative 33.
I got 198.
How do you get negative?
198.
Did you get 198?
I forgot the last x. Hold on. So I need to add 33.
33.
I got 0 then.
Why had it be 0?
I don't know.
Plus 12.
Yeah, I got 0.
You got 0? I didn't do this right.
Wrong.
You just like calculated it's done today or something. I don't know.
Or she's just the operator
Oh,
for
is your
shit.
calculator in
You're
degrees?
putting the cube in the whatever. Okay, you need to get in the habit of putting your exponent outside of the parentheses.
That's what happened to me. I wasn't even on that.
But it comes out minus.
I don't know what you're doing.
She did that too.
3
I see what's
minus
wrong.
3
What is that?
It's because
It's
it's
minus
minus
11
11,
times
reason why it's
3
minus
to
99.
There's more than
the second.
It's a minus
Oh,
one,
it
it's plugging in
11 times 3.
I know, but wait.
like this.
43.
Yeah.
42 and 46.
I don't know. It has to do with your
They're not that
times
bad.
3, whatever. So I'm gonna.
It's supposed to be minus 99.
And the remainder is whatever you got for this.
All right. So we're
And
gonna
then
do
46, you just plug
3.
in all 4 of these into this. Which is easy if you just go back in and insert every single time.
Oh, that.
I'm gonna do 50 if we have the ability to.
Yeah. Why does it come out to be 0? Did you guys get a 0?
I got 0.
Well, you put plus 99 instead of minus.
Oh.
Maybe I am right.
You might be right.
Now
She might be right. Because I put minus, I put plus 99. Maybe Ellie and her stupid calculator is actually right. Let's see.
Yeah, but
If you do that, okay. Let me go back. I'm gonna be so sad if she's right. I bet she is. Ah! Oh my heavens! It's 0.
are you sure about
Good job, Ellie. But oh my goodness. Yeah, I forgot to put a minus down here because that should be minus 99 instead of. Okay. So final answer. Use the factor theorem to determine if the given polynomial are factors.
Yes.
Yes. X minus 3 goes into, you don't have to write this down, goes into that.
Let's see.
X minus 3 goes in there perfectly. All right, what are we plugging in the second one? Negative 2. Okay, to see if he goes in there perfectly. So, negative 2
Negative 30.
to the fourth minus negative 2 to the third. 11, negative 2 squared. 11, negative 2. 12. This is 16. Plus 8 minus 44 minus 22 plus 12. 16 plus 8 minus 44 minus 22 plus 12.
Yeah, I got negative.
Negative 30. Yep, that's what I got. So, what's that mean?
No.
Not a factor.
Oh, that's not what I got.
He does not go in there. Ellie.
Ellie, don't even. 3 people got it.
I don't know what she's gonna go
The
on.
whole class got the last one.
Yeah, he was ended up being wrong. This one's not wrong though. I'm pretty sure. I'm pretty sure.
What'd you get?
Negative 30.
Sorry, you got?
I got positive 58.
How?
Oh, we might be done. We might be able to get done.
Either way, it's a no, so you'll be fine.
I mean, we could stop
But I
there
didn't
for
know
today.
what I'm doing
Easy
wrong.
lesson.
No, we gotta keep going.
But we could have an easy one tomorrow.
Yeah, but I'm guessing we're gonna have some questions to go over. So if you guys do this today, then we can go over questions
It's
tomorrow.
not that bad.
Okay.
It's not that bad. It's not that bad.
I need to know what I'm doing wrong.
I don't know why you're being so silly on What is happening?
Oh, she's using the pink one.
Because you put your square on the inside again.
Oh my goodness,
That's
Ellie.
on the outside. That's on the outside. That's on the delete.
Oh, that one.
Let's just answer and reset it.
Let me see. Insert
Have you ever
plus.
tried to do it?
No, I don't have it on my calculator.
Have you looked scared?
Yeah, Bill looked and he didn't have
No! Just go on with it.
Okay, you know what I'm gonna do? I'm gonna get rid of this negative. Because that's what it's gonna do.
Oh, so 50 is just what we just got done with, right?
See that? I'm gonna delete the negative, because that's all it's gonna do. Okay. All right. Ready, set, example 9. It says factor this thing down. Okay, this guy is a cubic function. And I don't know how to break him down other than doing like the factor by grouping thing.
Nah.
But can you pull anything out of 3x cubed and 25x squared other than an x squared? Like, that's not going to work. My groups will not match, okay? But it says, given that negative 5 is a 0. Cool.
Where's the negative?
Negative 5, given that negative 5 is a 0. All right. I'm going to put A over here. We know that negative 5 comes out of it. Negative 5 goes in there perfectly. If I were to plug negative 5 in there, I would get
0.
0. Okay. We're going to divide the negative 5 off, and I'm going to do it by synthetic division because that's the easier one, right? So let's go 3, 25, 42, and negative 40. And do I have to add anything in there? I don't think so. Okay. 3 goes down. 3, negative 15, 10, negative 50, negative 8, positive 40, and 0, like we should have gotten, right? Good, good. Very good, very good.
Is that literally what you should do?
Yeah.
That's literally the answer?
No, we're not to the answer yet. Now, what is this thing right here?
A trinomial.
That's a trinomial. 3x squared plus 10x minus 8. That's what he's left over. Now, can I break that thing down more?
Yeah.
Yeah? How?
8 and...
This is a complex trinomial. Can I do 3 times negative 8? Negative 24. What can you multiply to get negative 24? But when you add them, give you 10. It is not 6 and 4.
2 and 12.
Oh, wait, I just said that.
Because, yeah, so 6 and 4 is my first option. But if that's the case, then one of them has to be negative and one of them has to be positive, right? So it's either negative 6 and 4 or negative 4 and 6. And neither of those combinations will give me a positive 10. What is it instead?
Negative 2, positive.
Negative 2, positive 10, or positive 12, right? That combination is going to give me 10. So be careful, okay? So this is 3x squared minus 2x plus 12x minus 8,
Now
yeah?
we can do like that.
Now we can do the grouping thing. Blah, blah, blah. Okay, what are you going to pull out?
on.
X, just an X, and I have 3x minus 2. Okay, what do you pull out of the second piece?
4.
A 4, and left over is 3x minus 2. So my two bubbles,
Chloe, pause.
okay, I'm pausing. So I did I broke him down here into those two. Are we good? Okay. Okay, so what are my two bubbles?
X plus 4 and 3x minus 2.
X plus 4, which is this guy, and then 3x minus 2. Okay, now, he should have one more bubble. What is his last bubble? What was my first bubble? Yeah, my first bubble was 5 was a 0, so he should have an x plus 5 also in there. Okay, now it says factor that thing down. Okay, this is listing the factors. When it says factor it down, you don't set them equal to 0. If it said find the zeros, yes, go ahead and set each one equal to 0. But this one is just saying factor it down, just break it down. He is completely broken down into the 3 pieces. What?
That's only A? We have to do B still?
That's only A, yeah. We gotta do B now. We gotta do B now. Okay, this one is saying solve, not factor. This is factor. So when it says solve, we have to actually go one step further and set them equal to 0. So this guy is the same equation. We know that x equals -5, and then I have 2 more solutions, right? If x plus 5 is equal to 0, x equals -5. That's where I get my first 0 from, and they gave it to me. The other one is -4, and this guy is
Negative 2/3.
positive 2/3 should be, right? Okay, if I add the 2 divided by 3, so there are my 3 zeros. Now, I have 3 zeros. How many should I have gotten?
2.
Look at the degree. What's the highest degree? 3. How many should I have gotten?
3.
3, right? That matches up. Okay, unless one of them has multiplicity of 2 or whatever, I should get exactly 3 zeros. Make sense? Yeah, okay? All right, so that's the difference between where it says factor. Factor is just break him down. That's just list him as the parentheses. Versus solve means actually find me what x is. Make sense? So A versus B. Okay, B was kind of a continuation of A. Good? Okay, let's do this one real quick. Write a polynomial of degree 3 that has zeros that are 1/2, the square root of 6, and negative square root of 6. If the square root of 6 is a 0, I know negative square root of 6 is also a 0, yeah? Okay. All right, so what's happening here is we have that x equals 1/2. We have that x equals the square root of 6, and we have x equals -6. They want me to eventually get down to the point where I have x cubed, x squared, x, and my number, right? Like they want me to figure out what the polynomial is by multiplying all of the junk together, right? Okay, that's what we want to eventually get to. So I'm working backwards. If x equals 1/2, what did it look like in my parentheses?
X minus 1/2.
X minus 1/2. Okay, now I'm going to do this, and you can leave it as x minus 1/2 and certainly multiply it through by that. But I'm going to go 2x minus 1 instead, right? Does that make sense to you?
No.
Then I don't have any fractions, okay? 2x minus 1. So the way that we can figure it out first here is we're trying to get this guy equal to 0, right? So what I'm going to do is I'm going to multiply the 2 over. So I have 2x equals 1, right? And then I'm going to subtract my 1 over. So I have 2x minus 1 equals 0. This is what my factor looks like. That was kind of confusing. You can leave it as x minus 1 if you want to, but then you're going to have to FOIL with fractions, and we don't want to do that, right? So 2x minus 1 is what he will look like as his little bubble, okay? What about the square root of 6? What will he look like?
No.
You're ahead of me. He will be x minus the square root of 6. You're ahead of me. Just wait. Just wait. Right? Do you see how that works? Okay? If x equals negative square root of 6, and I bump him over, right? He will be x plus the square root of 6 equals 0, right? Okay? Do you see how this works? We're working backwards. Okay?
What?
Yeah? No?
What?
Okay, if I said that your factors were 2, -3, and 5, This guy in the bubble would be x minus 2. This guy in the bubble would be x plus 3. This guy in the bubble would be x minus 5. True? It's just like the opposite of that, right? So if x equals negative square root of 6, then x plus the square root of 6 is your bubble, right? X minus the square root of 6 is your bubble. This guy, x minus 1/2 is your bubble, except I can write that as 2x minus 1 instead of x minus 1/2. Got it? Ish. Okay? All right, so these are the three pieces that I want to multiply them together. Okay? Which two are you going to multiply first?
The last two.
The last two. Because these two are conjugates of each other, right? You remember when we multiplied conjugates and the middle two pieces like crossed out? That's what we're going to do, okay? So x times x is x squared. X times the square root of 6 is x square root of 6. The square root of 6 times x, this is minus x square root of 6, or you can just get rid of the middle part, right? And then what do you get when you take negative square root of 6 times a positive square root of 6? Negative 6, right?
You're foiling those guys?
Yeah, I'm foiling them out, okay? This is like negative square root of 36, or negative 6, right? So final answer, when I multiply those two guys together, x squared minus 6, right? Which is what Jack, did you do that in your head?
Yeah.
Good for you. Okay, you can skip that. You can skip steps. Very good. Okay, so x squared minus 6 is what he is multiplied together, but we still have to then
Do the other one.
multiply by 2x minus 1, and this one we'll just have to FOIL, right? Okay, so 2x times x squared, 2x cubed, 2x times negative 6 is negative 12x. Okay, I multiply the middle pieces together, I get negative x squared, and then multiply the end pieces together, I get plus 6. So final answer, 2x cubed minus x squared minus 12x. I flip these two around because I want them in order. And then plus 6. That is my third degree polynomial that has those three as zeros.
Those
That
on
makes
homework, you're gonna be the
We
difference.
have two of them.
Two of them?
Yeah.
Seriously,
I
ma'am.
love questions.
Oh, he's so for real.
Seriously?
One of them has eyes in it.
Love you. Oh, there they are, right there.
Yeah.
That's my stuff. Yeah. Yeah.
Hey,
Thank you.
Yeah.
this is
Thank
important.
you, man.
There you go.
We still could've just cheated.
Sure.
Why would we do all that work?
Right.
You're a little rat, homie.
You better believe it. Okay, we'll stop there because that's the end. Okay, do the homework. Do the homework, and we'll go over some questions tomorrow. Okay, good. All right, goodbye.